Hello friends, welcome to this session. This is Renu Yadav and you're watching me on AGL app. So today I'll cover the very first chapter of the ninth standard, that is number system. And today I'll cover the theory sections, some examples and the whole chapter in the point wise, that is points to remember, so that everything related to this chapter will be clear to you, and some exercise questions and some examples will be available to you in the form of PDF. And if you guys want me to have the session on the questions too, then you guys can do comment so that I can share the next video to you of the particular questions. So let's get started. So chapter first, ninth standard, that is number system. What are numbers? Obviously 1, 2, 3, -1, -2, -3, 0, 7 by 9, 7 by 9, or 10 by 100, 2 by 5. All are numbers. Clear? We'll study the numbers in its categories. Like if I write it down, number system. So we have the 4 categories. First one is natural numbers. Natural numbers. Representation of natural numbers is by the capital N. Second one is whole numbers. Representation of whole numbers is by capital W. Third one is integers. And representation of integers is by capital Z. And fourth one is typical category, that is rational numbers and irrational numbers. Clear? So rational numbers is represented by the capital Q, irrational numbers is by I. Okay? Which is real minus rationals. So what are natural numbers? Natural numbers are the numbers starting from 1, 2 and so on, that is plus infinity. Whole numbers are the numbers starting from 0, 1, 2, 3 plus infinity. This will become set. Integers, minus infinity, 1, -1, 0, 1 plus infinity. Clear? And rational numbers and irrational numbers both are in P by Q form. P by Q form, like this. 2 by 5 and 7 by 9. Where Q must be non-zero. Why? Because if Q is 0, the term P by Q will be undefined. So let me write this. And now let us clearly understand what are rational numbers and what are irrational numbers. What are rational numbers and what are irrational numbers? So rational numbers are in the form of P by Q, Q non-zero. Irrational numbers are also in the form of P by Q, Q is non-zero. Rational numbers are, we have, if we if we are differentiating, please understand, if we are differentiating rational and irrational numbers, we must be aware of the three terms, that is terminating, non-terminating, non-terminating, non-repeating, and repeating. Okay, so what does this terminating means? 2 by 5. This is 0.4 now. It terminates. It ends over here. Non-terminating 1 by 3. 0.3333 and it go on. And it goes on. So this is non-terminating. Third one is non-repeating. That means if your number is like 0.10, 110, 1110, it is non-terminating as well as it is non-repeating. That means 1 is repeating, 0 is repeating, but here only 1 comes for 1 time. Here 1 comes for 2 times. Here 1 is coming for 3 times. So it is non-repeating. What is repeating? This category is repeating. Like 1 by 3, 0.33333 and goes on. So I can write it down as 0.3 bar. Okay, so this is repeating. So rational number and irrational numbers falls under the category of real numbers. Every number is real number. Whether it is integer, whole number, natural number, rational number, irrational numbers and rational numbers, each and every type of numbers falls in the category of one number, that is real numbers. P by Q. So if I talk about 2 by 5, that is 0.4, it is a rational number. If I talk about 1 by 3, that is 0.3333, it is a rational number. If I talk about root 2, root 5, pi, root 3, these all numbers are irrational numbers. These numbers do not have a fixed value, that is root 2 is going to be 1.4 something something something, non-terminating, non-repeating. Irrational number is always non-terminating as well as non-repeating. Non-repeating. Rational number can be terminating or can be non-terminating. Can be non-terminating, but one thing must be there, that is numbers should be repeat. Okay, it must be like 0.753, then 753, 753, 753. It should not be like this 0.753, then 7753, then 77753. If it's happening like this, it is not a rational number, it is a irrational number. So I hope rational and irrational numbers are clear to all of you. In the theory section of this chapter, you have to study only two to four things. That is, you have to first learn how to represent root 3, root 5, root 2 or things like this on number line. First point is this. Second point, you have to learn how to represent 0.3333 in P by Q form or 1.272727 in P by Q form. And third one is exponential rules. These three things you have to study in this chapter. Okay, so I'll cover the very first part, that is how to show the irrational numbers like root 3, root 5 and root 2 on number line. I am showing root 3. You know by Pythagoras theorem is applicable only for the right angle triangles. If it's right angle triangle, this is A, B and C. If it's P, B and H, then P square plus B square must be H square. This is what Pythagoras theorem says. So root 3 is root 2 square plus 1. I can write it down root 3 like this, the whole under root. Right now? So I'll get root 3 if I have perpendicular, if I have perpendicular as root 2 and base as root 1, that is 1. So I can clearly have hypotenuse as root 2 square plus 1 square, that is root 3. I have to use the same concept to show this root 3 on number line. Let me draw a line. This is 0, this is 1, this is 2, this is 3, minus 1, minus 2, minus 3. Clear? So in your notebooks, how you children should do, you have to take scale and pencil, open the mark as 1 unit. Okay, 1 unit. 0 to 1 unit. If your scale is of 15 centimeter, na, what's 15 centimeter? Yeah, 15 centimeter, na. So you can take it as, open the scale for 1 centimeter. Clear? Or if you want to show the number line in a more clear way, then you can open up to 5 centimeter. Okay, and mark is as 1 unit. Mark it as 1 unit. Open the scale. Open your mark from 0 to 1, which is actually 5 centimeter, but you will take it as 1 unit. Okay. So that your representation in your notebooks will be fine. Will be looks in some visible manner. Okay. If you want, guys, if you people want the correct representation, then you should open for 1 centimeter. Okay. So this is 5 centimeter. Clear? Now from 0 to 1, it's 5 centimeter. 1 unit. It's 1 unit. 1 unit. 1 unit. Now again draw a 1 unit line or 1 unit perpendicular from this point A to this B point. This is 90 degree. Clear? And join this from this. Now this is 1 unit, this is 1, this is 1. So obviously this will be root 2 by Pythagoras theorem. Okay. Now draw a line from B to A. Sorry, C to A. I have already named the B point below. From C to A. So this point is C and this point is A. Okay. This is also 1 unit. Clear? Now join this from this point to this line. This is root 3. Clear, guys? This is root 3. Now you have to represent this root 3 or number line. So what you need to do is just take compass, pencil, place the one end of the compass over here like this, and place the other side over here like this, and try to draw the segment with the help of compass like this. So you will get a cut over here. This cut is nothing but the representation of root 3. Clear? This will look like this into your notebooks. So this representation is nothing but root 3. I hope this is clear to all of you. Now we will cover the next session. Next part is what? Yes, second part is I have to prove 0.3333 in P by Q form. I have to show. Very simple. This question is seriously very easy. What you have to remember is, if you want to show this type of thing, that is 0 point single digit bar, only 3 is repeating over here now, then what you have to do is simply take x equals to 0.3333 or okay, this is a rational number. So multiply, this is one number now, 3 is only one number now, so multiply it by 10. Multiplying it by 10. So what you will get? You will get 10 into x equals to 10 into 0.3333. So this is nothing but 10x equals to, what you will get? 3.3333 and so on. Am I right? Now see, can I write 3.33 as 3 plus 0.33? Can I write this like this? Now this 0.33 is nothing but x. From here, the 0.33 is nothing but x. So 10x equals to 3 plus x. Clear? Now this x is here, 10x. This x is here. Take it from here, left hand side. So you'll get 10x minus x equals to 3. 10x minus x is nothing but 9x equals to 3. You will get x equals to 3 by 9. That is 1 by 3. X equals to 1 by 3. Clear? So you have the 0.33 representation as 1 by 3. So 0.33333 is nothing but 1 by 3. I hope it's clear. If it's not clear, let me explain you with the help of another example, which is also an NCERT example. This first chapter is very easy. You guys need not to be worried about this. Second, if I want to show if I have to show 1.27277 and so on. Okay, if I have to show this in P by Q form, what I have to do is simply, you can clearly say it is nothing but 1.27 bar. Here 2 digits are repeating. Okay, so let me take this 1.27 bar. I can write it down as 1 plus 0.27 bar. Right now? So let's take this as x. Okay. So this is 1.27 bar is like this, or yeah. Now if I will multiply, sorry, it's not should not be done like this, it must be done like this. Like if I have 1.27 bar, so I have to multiply it by 100, so that this will become 127 point something like this. So yeah, simple. Let's take x equals to 1.27. Okay, multiply it by 100. You will get 100x equals to 127.272727. Okay, and this is nothing but what? This is 126 plus 1.272727. I can write it on this like this. You can see I have come to the x point. I have to change this such that I can use this fact. Okay, and how this fact comes? How I have written this? Just subtract 1 to 7.27227 from this. subtract this value from this. What is it? 1.272727 and so on. You get 126.272727. Clear? From this point I got this. So I have written it like this. So what I'll get? I'll get, this is 126. This is nothing but x. So it's 126 plus x. Take it from this side. 100x minus x. 126. 99x equals to 126. X will be 126 upon 99. Okay. You can divide it by 3. 4, 2 and 33. Again you can divide it by 3. Okay. So this is x equals to 14 by 11. I hope this is clear to all of you. Now we will cover the next part of this chapter. I hope these two things are very clear to all of you. Now I'll cover the third part. That is exponential forms. Exponential forms. Okay. What do you get when you multiply x from x? What do you get? X raised to power 1 plus 1. That is x square. Clear? When you multiply x into x into x, you get x raised to power 1 plus 1 plus 1. That is x cube. So how this comes? When the bases are same, powers are added. So I can say if x raised to power a into x raised to power b, then I can write it down as x raised to power a plus b. Clear? And one more thing. So from this it comes this. From this it comes this. One more thing. If I multiply 2 raised to power 2 into 3 raised to power 2, you will get 4 into 9, that is 36. Okay? And 36 is what? 6 square. And 6 is what? 2 into 3. Clear? So I can see 2 raised to power 2 into 3 raised to power 2 is same as 2 into 3 raised to power 2. So I can write this fact in the simple form, that is x raised to power a into y raised to power a is nothing but x into y raised to power a. Clear? So this is also your exponential form. In this first chapter, you don't need to learn things in a more, I don't think you can learn these type of things in more easy way. So next part is rationalizing. Fourth part is rationalize. 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 Whenever you find an expression written in your notebooks or books like this, but 1 by root 3, you always need to rationalize it. How you rationalize it? Just look at the denominator part, that is root 3. You don't have to do anything else. Just apply simple fact. Whatever is written in the denominator, multiply this whole term with the denominator, that is 1 into root 3 divided by root 3. This comes out to be root 3 by 3. Okay. Similar is for if it's written as 2 minus 2 plus root 3. Okay. And in denominator it is 2 minus root 3. What you have to do is your focus is always on the denominator. Why are you doing this? Because I don't want to see my denominator in this root 2 types. Okay. So if I have denominator like this 2 minus root 3, okay, so what's the reverse of this? Obviously the reverse of 2 minus root 3 will be 2 plus root 3. Okay, you know na, inverse of minus 1 is 1, minus 2 is 2. So if here is minus, then obviously reverse of this will be plus. Okay, so what you have to do is multiply with 2 plus root 3 upon 2 and divide the same by this. Okay, 2 plus root 3 into 2 plus root 3. What it comes out to be? When the bases are same, you can see power 1, power 1. When the bases are same, powers are added. So we have 2 plus root 3 square divided by, you can say a minus b and a plus b. A minus b into a plus b. This is nothing but a square minus b square. Clear? So I can write it down as root 2 square minus root 3 square. Apply the a plus b whole square formula over here. A square plus b square plus 2ab. And in the denominator part, a square minus b square. That is 4 minus 3. So I'll get 4 plus 3 plus 4 root 3 by 1. That is 7 plus 4 root 3. Clear? So this is how we rationalize. These type of simple and easy things are here in the very first chapter of the 9th standard. In number system, you have to be very clear of these type of things. So I hope all these facts are very clear in your mind, and I'll try my best to cover the rest of things if it rest of things in the next session, and I'll try to complete all the exercise questions in this session so that you guys can easily solve, and the PDF format of the solutions will also be available to all of you. What you have to do is just to download the AGL app. That's it. Thank you.